Hello and welcome back to Python. Now we wanna talk about the binary operation in, and yeah, you won't expect it, in Python. So what are bitwise operations? With a special kind of prefix, we can write down any binary number as or any integer as a binary number. For example, if we want to get our 8, we define a variable a, which is 0, b, 1, 0, 0, 0, and if we print it, we get 8 because of. And if we want to get 12, we get another, we get 1, 1, 0, 0, 3 ones for 14, and 15, of course, 4 ones. So if we want a video containing how to calculate with binary numbers, anyways, I can make a very own video of that topic, how to convert a usual number or usual integer into a binary number. But I guess if you are watching this video, you already know how to convert a decimal number into a binary number, and how to convert a binary number into a decimal number, and how to convert a decimal number into a binary number. I hope I got all directions now. So after we know how to write down a binary number, let's do our binary operations. To test our binary operations, I will just write down another binary number, and I will alter the first binary number. By the way, if we are typing down a 2, we will get an error because invalid digit 2 in binary literal, because 2 is not part of binary code. Yes. If we print our second binary number, we should get a 10. Yes, okay. And now let's print a new integer, or a new integer using our very first binary operations, a and b. So with this binary operation we get 10. Why do we get 10? Because if we write down the two numbers and using an AND operation to every bit, as a quick reminder, 1 can be equal to true, and a 0 can be counted as equal to false. So if we have 1, 1, 1, 0, as you see here, 0 and 0 is false, 1 and 1 is true, 1 and 0 is false, and 1 and 1 is true. So a and b gives us a 10. Now if we change the first number of our b to a 0, we will get a 2. And if we change the last number of our b to a 1, we will get we will also get a 2, but b is then of course 3, so we won't get always the same number as b, because the last 1 and the last 0 is a 0 if we're using AND operation. At this point I will just show a picture which should illustrate what I'm trying to explain, and here you can see the picture. And let's come to our next operation, which is the OR operation, a or b, bitwise. Now, as you may know, using an OR operation on two booleans, only one boolean of every boolean has to be true. So in a bitwise operation, we get a 1 if the first or the second digit is a 1. If both are 0, we will get a 0. So if we compare A and B, at least every digit has a 1. So the last digit, for example, there is a 1 at B, and the second one there are both have a 1, and yeah, in the last two A has 1s. I will show another picture now to illustrate what I'm trying to tell. So the next operator we wanna look at is the XOR operator, which is just the roof sign here. And yeah, the XOR operator gives us true when only one of the compared bits is true. So for example, if we have, let me change that to 0011. If this number and this number contains in general only 1 and 1 0, we will get true. If both are 1 or both are 0, we will get false, or we will get a 0. So in this case here, the case I'm marking, we will get 1 0 0 1, because the first one, if we compare these bits, we get it's a 1. These ones are a 0, these ones are a 0, and these ones are a 1. And yeah, A is 1 1 1 0. So these two bits compared will give 1s. So this should be the right output. And yeah, we can even print it as a binary, I forgot to mention. If we are using the function bin or bin, we'll get the binary number of a number. So keep that in mind. Okay, next I want to show the bitwise not operator. So the bitwise not operator, so as a prefix we are now using I will call it the wave sign, because it looks like a wave. I don't know the English word, but you all will get what I'm telling you when I call it the wave sign. So using the wave sign, for example, and a 5, we will get -6. Why do we get -6? Because as a 2 complement, the binary code for -6 is 0, is for 5, I'm sorry, is 0 1 0 1. Yes, and the 2 complement of this is 2 1 2 1, which is the inverted binary number. So while the first one has the ones on the second and last place or spot, the second binary number has the ones on every spot the first one doesn't have. And that gives us a 2 complement, and the 2 complement of form of 1 0 1 0 is -6. If I want to know the 2 complement, I for myself have my very own way by just counting the zeros, the spots on where the zeros are. It is on the spot where the 1 is, and the second one is the spot where the 4 is. We add them, get a 5, add another 1, get a 6, and then -6 is the solution. That's for how I get the negative numbers when I have a two complement. That's my very own way I gathered for myself. But there are many ways how to convert or how to read a two complement. So the last operators I want to show you are the left and the right shift. So if we have a binary number like this, and we then and we are reading the binary number, we get 4. And if we take the 1 and shift it 1 to the right, or shift everything to the right, we get 0, 0, 1, 0, and the last 0 ends in the void and was never be seen again. Or like this one, we have 0, or we have 1, 0, 1, 1 equals 4. And now we equals not 4, I'm sorry, this one equals 11. And if we shift every bit to the right, we get 1, 0, 0, 1, 0, 1. And another bit, this time a 1, leaves our world and enters the void. So what we are simply doing is we are shifting, or we call it right shift. So this is now a 2. This turns from an 11 to a 5. And if we print 4 shift 1, we are getting 2. The same goes for 11 shift 5. 11 shift 1, I'm sorry. We get a 5. And if we can also shift it, we can also use shift 2. Then we repeat this process only, so the next one will be 0, 0, 1, 0, and this will be 2. Okay. Of course, we can do the same in the opposite direction. So we get, if we do a left shift with a 2, we obviously get a 4. 2 times we get an 8. Why do we get that? So we have our binary number, which is a 2. And if we shift it 1 to the left, the first number, or the first binary number, will turn into nothing. And this 0 I'm marking, this 0 is now put on the right. And if we do this 2 times, 2 zeros will turn into nothing, and another 2 other zeros will be added on the right side. So this is left shift and right shift. So this was much input, I guess, and maybe if you didn't ever handle binary code, it may be confusing. I hope you could enjoy this video anyway in some kind, and see you. Bye bye.